Today we are talking about the NOR gate. Okay. So the NOR gate is a combination of two gates, which is the OR gate and that of the NOT gate. Okay. So the symbol for the NOR gate is a combination of both and NOT gate and then the OR gate. So the symbol for the OR gate, which is in this form, so this for the OR gate. So this is for OR gate. Yes, so this for an OR gate. And then the NOT gate is in this form. So the combination of these two will give us a NOT gate. The combination of these two will give us a NOR gate. Okay, a NOR gate. So this brings this. We have a NOR gate, or we can still have it. I got it. We can still have the NOR gate in this form. So the NOR gate can also be written, sorry, can also be drawn in this form, where we have this here, and then it goes down there. Then we would have our small circle here. Then we have the output. So this is another form of NOR gate. Okay, we have a combination of OR gate and that of the NOT gate. Now we know that the NOT gate is responsible for producing the opposite of the input. Okay, and then we have the OR gate, which requires at least one positive input. Okay, the OR gate requires one positive input to produce a positive output. So you just have to combine these two to get your truth table. So let's say I have the first input to be A, and then the second input to be C, and then I have here to be Z. So A and C are my inputs. A and C are my inputs. So I have A here, and then I'll just have my C here, and then I have my output. Yes. So A and C are connected to a NOT gate, which can be represented in this way. So if I have 1 here, I could have 0 here, I could have another 0 here, I could have another 1 here. The values here depends, okay? It could all be ones. It could all be ones or all to be zeros. So I have C. So let's say I have C 0 here. I have 1 here. I have another 0 here. I have another 1 here. So ideally, for OR gate, the first part should give me 1 because The OR gate requires at least one input to be positive before I get a positive output. So when I say positive, I'm talking about one. Okay, the positive means that it is on, which is one. So over here, because the output supposed to be one, but we are having a NOT gate attached to the output, which is supposed to be one, the output now serves as the input of the NOT gate. Okay, so let's see from here. I have A to be one here, and then I have C to be zero. Okay, so this part is the final output. So 1 and 0 for all gates should give me 1 as a what? As an answer. So over here, I will produce 1 here. But this one produced here will serve as the input to this NOT gate, and it will bring the output here. And we know for every NOT gate, it gives the opposite. So if 1 is produced here, then definitely you have our 0 being produced here at the output. So we'd have 1 and 0 will give us 0. Okay. Then we have 0 and 1. So 0 and 1 is almost the same as this. We still have our 0. We have both to be 0. So both to be 0 will give us 0 here. And this 0 will be converted to what? 1. So I would have 1 here. And then I have 1, 1, which will give me 1 at the output. But to the NOT gate, it will produce 0. So I have my 0 here. So some people actually don't understand how the NOT gate works with other gates. Okay, so you to avoid any confusion, just draw it this way and then apply this input and then this gradual process to get your final answer. Because this seems to be a fused diagram. So if you don't take care, you will just mess up. So just go by this. Use this input, apply the rules. For all gates, at least one supposed to be positive. So in the moment one becomes positive, then the all gate will give us a positive result. Okay, it will give us a positive result. But this result will serve as the input to this all gate, not gate, sorry. So this will serve as the input to this not gate, and it will give us the opposite of that. So that gives us these answers. So input of A 1001 and then C 0101 will give us an output of 0010. Okay, so this is how we solve this type of questions. So there are situations where several gates can be fused together, which we call the combinational gate and out of the sequential gate. Okay, so I'll take you guys through a few examples and then we end the lessons and then we end the lessons on this topic. Okay. Yes. So there could be a question where the OR gate, AND gate, and that of any other gate are put together. Okay. So for example, if I have an AND gate like that, this is AND gate. Okay. Don't forget the symbols. Don't forget the symbols. So this is an AND gate. This the first one that I just finished drawing is AND gate, and then we could have another one here which will be OR gate. Okay, so this an OR gate. So let's say this OR gate is connected to a NOT gate. Okay, yes, this is connected to a NOT gate, and this is also connected to that. So we have AND gate, the output of AND gate connected to the output of a NOR gate.